chain rule. Let's stop here. In our previous videos, we dealt with different methods of differentiating different kinds of functions. Precisely, we looked at some rule of differentiation. We looked at product rule. We have also studied in this channel the quotient rule. Okay? Alright, so this video is going to teach us how to, use the chain rule to differentiate functions of real variables. Okay, chain rule. Okay. So precisely that is our goal for this video, to study the chain rule. That will now complete the different rules for differentiating functions depending on the nature of the function. We see if we have the sum of two or more functions, the best approach is to use the sum rule. If you have the product of two or more functions that are differentiable, the best rule is to use the product rule. If you have the quotient of two differentiable functions, we apply the quotient rule. Now, if we have what type of function can we apply the chain rule? Okay, so suppose we have a function of the form y equal, say, u raised to power, maybe n, where n is any power of u, and u is a differentiable function. U is a differentiable function of x. So if we have this type of function, the chain rule says that to differentiate y with respect to x, we should first differentiate y with respect to u, because by this we have written y as a function of u, and then u is a function of x. So we differentiate y first with respect to u, and then we multiply it by differentiating u with respect to x. So if we do this, then whatever we're able to get from here is the derivative of this function y with respect to x. For example, suppose I give y is ax plus b, for example, raised to power n. And the problem is to find, we want to find the derivative of y with respect to x. If you observe what we have here and the introduction I made, you will see that we can rewrite this in the form u raised to power n, where u of x is nothing but ax plus b. Here, a is a constant, b is also a constant. So I've written u as a function of x, of course differential, because this is simply a polynomial. And then if you have been watching my video, you see that I said, we saw in one of the videos, that every polynomial function of x where the r is differential with respect to x. And so this is differential with respect to x. So applying the chain rule, so dy by dx, so I'm trying to solve this, is nothing but the derivative of y with respect to u multiplied by the derivative of u with respect to x. Okay. To differentiate y with respect to u, we see that this is u, y is just but u raised to power n. If you recall, we saw that if you have a function of the form y equal ax raised to power n, then the derivative of y with respect to x is simply n multiplied by a, x raised to power n minus 1. This is what we have. And if you observe this and this, they are the same. X, u, they are dummy variables, so you can navigate as you like. Our a here is 1. So applying this, dy by du is simply n u raised to power n minus 1 multiplied by Who is our u? Our u of x is ax plus b, so that the derivative of u with respect to x is simply a, because of course if you differentiate a constant you get 0, and then if you apply this here you get a. How? Look, for those of us who are learning this course for the first time, I don't like assuming anything. If you look at ax and you look at ax raised to the power n, then our n in this case is 1. So if we apply this formula, dy by dx is na x raised to the power n minus 1. Our n is 1, so I have n times a x raised to the power n minus 1. This is n is 1, I have 1 times a x raised to the power 1 minus 1, which is a x raised to the power 0. And any number raised to the power 0, where that number is not 0, this will give us 1. So we have a times 1, which is a. Therefore, the derivative of u with respect to x is exactly a. So we put that in here, and this gives us a. And when we simplify, this is nothing but n a u raised to the power n minus 1, who is nothing but n. And then I have a, who is our u? Our u is ax plus b raised to the power n minus 1. Whatever our n is, we plug in here, we simplify, and we get our result. So this is how we can differentiate a function applying the chain rule. We will take more specific examples so that we will enjoy the beauty of this formula. So that's the next thing we need to do, to take precise examples where I don't have a to b any constant, b any constant, n any power. So I'm going to fix n, I fix a, I fix b, so we see how it works also. All right.